Welcome back to VTU e-Shikshana program. In previous session, we came to know that how to draw projections of points in first quadrant, second quadrant, third and fourth quadrants independently. Now let us discuss how to draw side view of a point along with front view, top view. Now let me take a model and explain how to draw side view of a point. Now take this model. This consists of horizontal plane and vertical plane, horizontal plane, vertical plane and side plane. This side plane particularly referred to as right profile plane. If I have one more plane, this side, this is left profile plane. Now let me concentrate on right profile plane and then draw the side view. Since the given problem now is the point is 50 mm above HP and 30 mm in front of VP and 40 mm from RVP. Let me assume this particular point A, you can see, and this particular point is 30 mm in front of VP, 50 mm above HP and 40 mm from RVP. That means this imaginary plane containing the point is mutually perpendicular to both HP and VP but parallel to VP. Okay. Now, how to draw the projections? You know how to draw the projections with respect to HP and VP. You have to draw a vertical projector that is going to house both top view and front view with XY line. Okay. Next, this is A dash, this becomes A, and if you project this point A on RPP, you will get A double dash. Now, let me rotate the horizontal plane 90 degree clockwise. You will get a single plane. This becomes 2D. Again, the plane which is referred to as RPP is a still perpendicular. You have to rotate on par with HP and VP. Now you can see this is XY line continued up to that. You can say actually reference line is from this to this, but for drawing purpose we draw up to the side plane, and then we call this particular reference as X1, Y1, and this area is referred to as RPP. Now why this is referred to as RPP? This is side plane, it is also referred as profile plane. It is to the left, right side. Now left view on right plane you get always. Now how to represent this RPP in drawing? Now let us have XY line and then draw perpendicular to XY line. You call it as X1, Y1. I will explain that with the drawing software. Now same way we can draw the right view on left profile plane. Assume that one more point A is 50 mm above HP and 30 mm in front of VP and 50 mm from LPP. So the distance from this point to this point is 50 mm. So again this is top view, this is front view and this one is side view. How to fix the distance of the LPP or RPP from vertical projector we will discuss in future. At the same time, I would like to give one more information regarding the position of points. Assume that there is a point on HP and in front of VP. Where exactly you get the top view? This point itself is top view and you project it and get the corresponding front view on XY line. That means whenever the point is on HP, the corresponding front view is on XY line because zero distance from HP. HP distance is always to measure, mark the front view. Similarly, whenever there is a point on VP, the corresponding top view is on XY line. That is 30 mm from in front of VP means 30 mm below XY line you get. Here it is zero distance because it is on VP. You will get on XY line. This also I will explain with a particular problem. This particular problem refers to side view of a point. A point P is 50 mm above HP and 30 mm in front of VP. The point is 40 mm from side plane. Draw the projections. It can be left profile plane or right profile plane. Normally, by default, we take right profile plane. Here is the first quadrant representation along with the side plane, particularly RPP. You always know that the object is in between plane and the observer. Whenever you project a point, you will get in the opposite plane, reference plane. So, here is point 50 mm OHP, 30 mm in front of PP, 40 mm from RPP. This point is referred to as top view, this is front view, and this is side view, or it is also referred to as left view on RPP. Okay, left profile view on right profile plane. So, take this as reference. We know that how to draw the projections of a point with respect to HPAP. The previous session we have worked out this problem. Same problem we have worked out, 50 mm OHP and 30 mm in front of it. This is XY line VPHP. Now I am indicating the procedure. Draw top and front of a point P dash and P. Now how to fix the side view? Side view is 40 mm from LP RPP. Now how to fix this? So draw XY line, continue, and then fix 40 mm from this. You just see this imaginary plane containing this block, that is rectangle, is 40 mm away from it. That means you have to take 40 mm away from this and draw one more line. Let me call this line, this reference line, as x1, y1. And if you look from left side, the RPP looks like L shape. How to draw it? Now I will try to keep 40 mm from RPP to fix RPP here. Then you have this line x1, y1. Let me call this as RPP, and inside you will get L shape. The vertical line of L shape is VP and horizontal line of the side plane is HP. Draw 45-degree line to obtain the side view. Why you draw 45-degree line? Why not any other angle? For information, if you draw 45-degree line and project it, you will get same distance in front of VP. Okay, so that's why we draw 40. It is a like square concept. If you draw square and if you draw diagonal, you will get 45 degree as the inclination and all sides are equal. See, in this case, we have to draw 45-degree line only, not any other angle, to get the side view. Now project top view through 45-degree line and project directly front view. It gets you side view. So let's see how it works. I have drawn projection through 45-degree line you have to take. Now many times what happens, people keep projected beyond this 45 degree. No, you are going to commit mistake. Stop at this point. Don't move further. Then take towards RPP. So this is how you do it. Next comes directly project front view. Intersection of these two projectors from top view and front view gives side view. You have to mark this point as P double dash, and that is the final answer for you. So this is the final answer. Take P dash and P as usual. You draw top and front views in first quadrant. This is the first quadrant pattern actually, and then 40 mm you have taken. You just observe here, I have taken dimensions outside the overall figure. You should not keep dimensions inside. See this 40, it cannot be like this. I will just show you. It cannot be like this at random. So always you manage to maintain this on line, one single line you can say, preferably single line, and then keep this 40 neatly. Maintain 1 centimeter to 1 inch gap from the overall figure. So this is the better way of working, good presentation say. Again I will repeat, P dash is front view, P is top view, and P double dash is side view. This is actually left view on RPP. Okay. So this is about getting the side view of a point. So let me discuss same thing in the alternate way. Instead of RPP, I want LPP to be considered. That becomes right view on LPP. Look from the other side, that is right side. You will get the projection on LPP, and as usual you have to draw top and front views. Instead of getting right side, you have to get left side. This area is LPP, similar to the RPP, VP, HPF or LPP. Then project through 45-degree line, directly project front view, maintain 40 mm from the vertical projector of P to fix x1, y1. So this is actually referred to as x dash, y dash. This is x dash, y dash. So this is the solution for the problem which is having LPP as the reference, right view on LPP. Now let me take a problem in third quadrant. Same concept. Instead of having point in first quadrant, you are having point in third quadrant. Here the plane is in between the observer and the object. This is the object, this is the observer, in between plane is there. Whichever the side you look, to that side only you have to project. So in case of LPP, left view on LPP, right view on RPP. So here there is no confusion. Whichever the plane you look at, you get on the same plane because you are the other side of the object. So here I have shown you the HPVP LBP reference. Okay, now let me take this. I have taken LPP. Why I have given gap? Because I have to create LPP. Okay, you know very well how to create, because it is below HP, below XY line. Behind V means above XY line. So I have already given this table. Okay, so how to keep this? See, behind VB means above XY line, and above HV means above XY line, below HV means below XY line. See, these are the references. You can always say. Only for top you have to think twice. Okay. Also the side view of a point. Now how to get this? Now let me take up a specific group of problems. This is very much essential for projection of straight lines, because one end of the line may be anywhere in space, first quadrant. Normally from straight line onwards we discuss the problems which are in first quadrant. Okay. Now how to draw this? Already I explained, whenever it is on HP and in front of P, how to do it. See, here A is 40 mm above HP and 25 mm in front of it. It is very familiar to you, already I have drawn. And I have taken a single XY line, and then I keep all these answers in this. In examination or classroom work, you may get a problem like draw the projections with 20 mm away from each other. So you can maintain, otherwise you can maintain any suitable distance, do it, otherwise independent also you can do. Now let me, for convenience, I will take this 40 mm. Don't keep HVVP anywhere, because HVVP now it will change from point to point. This particular problem is refers to first quadrant only. Anyway, to avoid confusion, don't keep HVVP. So 40 mm above HP. I will keep 40 mm line, because 40 mm above HP means this becomes front view. So this is A dash, small letter always, projection always small letter, A dash, 40 mm above HP, and 20 mm in front of. In front means 25 mm in front of means 25 mm below XY line. So keep this 25 mm in front of means below XY line. So now check whether it is correct or not. Yes, 40 mm, and this is, see, this is showing different. So check it, immediately change it. Sometimes it happens. Okay, now name this as A. This is A. Try to relocate if it is away from the specific reference. Bring it near, because in computer work this is common. It will be a little bit away or like that. Now try to mark dots. Okay. Point. Here is the width in to solid is 25. We are not getting for the 2 mm width, but I will keep little higher, say 50, and mark. Better you keep black only, because you work for class work and exam, black only. Now see, this is how you get, just you can see the dot here, 40 mm OHP, 25 mm in front of VP. Okay, so this is about the problem point A. Now let me take point B. On HP and 25 mm in front of, on HP means on HP means on XY line, no distance from XY line. So take this point on XY line. This is referred to as B dash. This is B dash, front view. 25 in front of means it is below XY line. Keep 30 mm, 25 mm. Mark point here, just to represent the view. Again, same procedure you have to follow every time. Whenever you want to put point, you have to keep this. And initially see that this is 25. Okay. Just see before keeping it, just see that this is 25. Yes, 25. And then mark point. See that it is exactly at the same position wherever you have kept. End of the line. Next point is C. C is on VP and 40 mm above HP. So the point which is above HP means above XY line. There is no change, narrow concept. The front view is above XY line. So mark that first. Always you prefer to have the point which is for HP, 40 mm above HP. Sometimes thickness you have to change before starting. So same thing, this repetition is there. Better you avoid this. Now C, this becomes C dash. Mark point at the end of this. Actually, you cannot see any point here unless you keep little bigger size. Yeah, it is 50, definitely it is 50. And one more point here, because it is on VP means on XY line. You get both points. This one is C. Sorry, C. Now dimension it. You can ask me why not we keep C above XY line, why not B below XY line? Yes, we assume that always the point is in first quadrant. So whenever the point is in first quadrant, you always have the top view below, front view above. Based on that concept, you can keep C below. Even you can keep above, that becomes second quadrant, because it is common to first quadrant and second quadrant. The last point is D. It is both on HVP. It is coinciding with the reference line. That's why 0 distance from HP, 0 distance from VP. Definitely, you have to keep one single point on XY line of given thickness, say 50, and mark here. Okay. Now, what do you name this point? So, this is actually D dash and D. Again, you can question me, why not you keep both letters D dash comma D, D dash comma D below, etc. or interchange. Yes, you can do it. It all depends on the assumed quadrant. Here, no quadrant, it is common point for all quadrants because it is at the center point. Definitely, you can assume it is in first quadrant. We are in first quadrant and then keep D dash and D. Okay, so this is about the projection of points. Okay, basics. We have discussed so far the points independently, and then the points which are on HP, on VP and touching both HP and VP. Now let me consider the problems which are little bit tricky. Okay, and let us work out that. I have a problem. A point Q is in third quadrant, 45 mm below HP and shortest distance from the intersection of HVP from the point is 75 mm. Draw the projections. Similarly, we have the problem in first quadrant reference. The point P is in first quadrant and 45 mm above HP and short distance from the intersection is HV and VP. Actually, you can see the side view of a quadrant or side view of the reference coordinate system. Always we refer quadrant VP HP as L shape, and that also gives you side view of the reference. Now you can see he has given 45 mm above HP. Yes, I have taken 45 mm above HP, drawn the locus of actual point P. But I don't know how much it is above HP, but he has given the shortest distance. Whenever you assume a plane which is mutually perpendicular to both HP and VP, on that plane you keep the point as I discussed in the model. That becomes your shortest distance parallel to the side plane. So whenever there is a line parallel to a particular plane, on that plane you get true length. That's why I have taken an arc of 75 mm and then drawn this situation. This is position of point as per the given data. It is with respect to the first quadrant. This is the shortest distance. No other distance can be shortest distance because it is with HP and VP intersection. Now how to go about solving problem? Now you know very well that in previous problems, two problems we discussed, this is the format, first angle projection or first quadrant format. This is VP, HP of RPP, and this is vertical projector of a point. This can be any given distance unless this is specified. Here this is a tricky problem where we want to find out something which is given, like find the distance of the point from VP. Since the distance from point VP is not given, so that's why we have to find out. This is not given, we can assume. Now, according to this, in the previous figure, this looks like side view. Yes, see, side view only. If you look at the quadrant from side view, it looks like this. It is very clear that we have to take the 45 mm above HP, mark a point on vertical projector and mark P dash, I can directly mark, and P double dash we have to keep it in side plane. So this is very interesting. This is side view reference. P actual point is going to replace by P double dash. That's all, nothing else. Now let us mark point P 45 mm above HP. Point 45 mm above HP. we did with black only. Now dimension, distance between two reference items. One is point, other one is XY line. See, this is 45 given. This point is referred to as P dash. P dash we got it. So please observe that I have not placed this any of the dimensioning line or naming inside the overall figure. Sometimes it happens. You have to keep it because y, x, y and all. You have to keep it. So here I have directly taken VPHP. That's why I have restricted y here only because this is the reference line. Otherwise you can keep x, y up to this and then x1, y1. So here let me mark x1, y1 to avoid any confusion. x1, y1 or x dash, y dash. Okay. This is RPP. Project front view directly towards RPP. We don't know where exactly it is. Let me identify the locus. That's all. After that, let us draw an arc with 75 mm so that you get the shadow distance fixed. On this, you get the P double dash. Now, the procedure is first you have to have the pattern, then draw this and identify the locus. This becomes locus of P double dash. See, this is the locus of P double dash. Then you take, as usual, draw an arc with 75 mm and this point gives you P double dash. Identify that as P double dash. Okay. This is front view, this is side view. Using this reverse procedure, normally used to have front view and top view, then we get the side view. Here side view is available, front view is available. Then we have to get projected back and then leads to the identification of P here. So it is reverse procedure. Draw this line. This is actually a projection from the side view towards the HP area so that you get top view here. Now intersection of vertical projector of P and projector from P dash through 45 degree line gets you actual P. Now this is P. The question is find the distance of the point from VP. The distance from point from VP is how much it is below XY line. So measure this and get this value. So answer is the distance of the point from VP is 60. So if you measure this, it definitely gets. It may get some fraction, that all depends. Here I have a simple mathematical concept, Pythagoras theorem, 3:4:5. See, this is 15 3s are 15 4s are 15 5s are. So definitely you can also calculate if you get, otherwise you can calculate using Pythagoras theorem and do it. But keep it safe and neatly. Presentation is very important. Procedure also they will see.